All right, so in this example, we are basically, this is called a test of independence. Test of independence or homogeneity. And what is this test? It tests one categorical variable against another categorical variables. It tests if there is a contingency or rather independence between those two variables. And since in the test of independence, we state the null and alternative hypothesis in words, we're gonna, the table consists of two factors. The null hypothesis states that the factors are independent, and the alternative hypothesis states that they are not independent or dependent. So let's apply this thing here. It says, which political group, liberals, moderates, or conservatives, would you expect to express the most happiness about their lives? Okay, so we have two variables. We have political groups, and we have how happy they are in their life, or happiness level, right? Happiness level. Okay, so which is explanatory variable, or and which one is response variable? Well, it says happiness should depend on the political groups. That's what we're investigating, right? So explanatory variable will be political group. And the response variable is the happiness level. Level of happiness. All right, so this is categorical. Actually, both of them categorical. And remember, if you wanted to present this data, you could do a stacked bar chart. It's one of the ways we could do, the box plots too. All right. Is this an observational study or an experiment? I'd say this is an observational because we're not treating our subjects, right? We're just observing. All right. So we would fit the test of independence. We would do the test of independence here. And here it says complete the chi-square test for the happiness political groups problems by hand. I'm gonna do it using technology. All right, so let's do this. Okay, so here we are. I transferred our data into this into Statcrunch. I have my column labels in the first row that is called level of happy, and then I have my levels in that column, labels for the groups. Okay, so what we're gonna do, we're gonna go to stat and select independence. Sorry, we're going to stat tables and then contingency, with summary. We don't have original data, we have summary. So for my columns, hang on. Sorry, I had to move everything up one level so that we have our column headers in the proper place. I don't know what I was thinking. But anyway, so we go to stat tables, contingency with summary. And then we select our the columns, and they're basically, you start here with liberal, you hold the shift key down, moderate, conservative. Those are our columns. And then for the row labels, our row labels are in this column, level of happy. So select that, and you're gonna scroll down and perform the chi-square test for independence. That's where we are, and hit compute. So here we are, we have everything that we need for our test. We have our, we have basically matrix with our totals for the rows and for the columns, and the grade total, just in case you need it. But what we want is basically our test statistic is right here, 22.45 for 373. So that's your test statistic, and we have a p-value of 0.0002, and it's extremely small. It's a very small p-value. All right, so let's write it down and go from there. So the test statistic is 22.454, and the p-value is 0.0002. Okay, so, and it is less than 0.05, I assume. Again, I'm assuming a lot lately. I'm assuming that our level of confidence is 0.05, and my p-value is smaller than that. So that means that we're gonna reject the null. Okay, and what was our null? Our null and I just realized, guys, that we did not actually write what our null and alternative is. Okay, so here it says set up the hypothesis for this test, and the hypothesis for the test of independence are always the same. They will not change. So the null says it's basically a statement that the row and column variables are independent, right? The row and column variables are independent. Okay, and the alternative will say that the row and column variables are dependent. Okay, so we got that, and then let's go back to our test statistic and the p-value, and we rejected the null, which stated that the row and column variables are independent. So that means that we're accepting that the row and column variables are dependent. So our conclusion will be, conclusion, the row and column variables are dependent. So what were our variables? The political groups and happiness levels. So they're dependent. So we're going to say that the happiness level of a person depends on which political group they're actually they belong to. So conclusion, the level of happiness is dependent or correlated on a political group the person belongs to. Okay, so this is how you conduct the test of independence. So basically, for your project, for your final project, you're gonna select two variables. You're either gonna have quantitative, compare quantitative with quantitative, then you're gonna do the linear regression test, or you're gonna compare categorical to and numeric, and then you're gonna do what are you gonna do? You're gonna do the goodness of fit test and or categorical versus categorical, and then you're gonna do um, this the test of independence of the variables.